think actually I was flying together with Lars, and I said, Michael, what happens if you don't have any boundaries to your designs? What happens if? How can we do? Is there any constraints? And I think that our process is sort of like curiosity on a scientific level. We are here to talk about the M1 speaker. There are, of course, when you do a speaker, many choices you take, and all of the choices constitutes a compromise. What if you took that compromise away and says, okay, what is the purpose of each part? What happens if you just let go of everything and simply in every tiny little aspect do the best you can? And the idea is behind the M series of speakers, and the M1 in particular, is that if you don't try, you will never know. So the next question was, what does this piece of material actually contribute? And we know from all our past work that there are a few materials that sounds really, really good. And I said, gee, what will happen if we made the basket from 3D printed zirconium rather than aluminium? And Lars was pretty quick. Why have we not done that already? He says, first you need to get the idea and the understanding and all the things that goes into making speakers, that this is actually important. And once you do that, you ask yourself how is it going to look? And one thing that was very clear from the get-go was that when you look at a speaker driver, there are a few elements that really defines how that driver sounds and how that driver performs. It must have sympathetic resonances, and you must choose materials that by nature has sympathetic resonances. And we looked into various designs. I made a lot, and then we stumbled upon this 3D optimizing, where we topology optimize, where we look at what does this piece of material actually contribute: stiffness, damping. So every single sort of tiny little material has been looked at from artificial intelligence and see what does that do of any good. And the result is that we get a basket that looks like this. And for me, it's sort of like, it looks more like a root on a tree than a normal and typical basket. But this is optimized so that for the amount of material we get the highest possible stiffness. So we have this oddity of a basket. And it was very funny the first times we were testing them, we were not expecting what this did, because the sheer contribution in terms of impact and focus and lower noise was just enormous. And of course, when we start looking at something like the basket, we also look at all the other elements we have in the driver. I have a complete driver here, and when you look at it, you see it's the best version of our ironless magnet system. And the pole pieces that are normally made from iron are made here from silver. So silver put into a small electromagnet like the voice coils is, they don't like the chains. And the result is that when you look at a measure for that is inductance in the voice coil. When you look at inductance in the voice coil, then in this system, it has only 8% of the flux that you have when you just have the voice coil out in free air, and even less than it would have in an iron gap. And if you want to ask, how can you paint a picture that shows what it does, you can look at the music bouncing off the floor, essentially. You say have music bouncing here. When you have an iron-based, you have a thick carpet on the floor, so it bounces not as well. But when you have this magnet system, it's a concrete floor, or it's an extremely hard floor, so it bounces really, really well. And the result is that you get a better dynamic range in the speakers. Of course, the membrane had to be a special case as well. And this one ended up being a sandwich of different materials. And I think it's ideal in so many aspects. It's lightweight, it's extremely stiff, it has very high damping. It's an unbelievably good membrane in all classical aspects. But making a membrane that consists of a 4/100th millimeter titanium skin that has been subjected to particle acceleration coatings, a honeycomb sandwich, and a carbon skin layer. Building that up is, we can do one membrane in a day, and especially during the development on the cone of these drivers, we have had a lot of iterations and a lot of, we think we understand what goes on in the membrane ideas. You can make something that on paper looks extremely well, and then when you start listening to it, you said, oh, yeah, that was a good idea, and throw it in the bin. And then we said, okay, why was it that this good idea was not really the correct approach or the right way to go? Because sometimes you have to revise what you thought before you sort of see the light and say, this is why, and now we know how we can. And once you have these 3, 4, 5 different fragments of understanding, then you can maybe push performance to a new level. So the challenge here is, can we make something that is as good looking as well-performing? And I thought that, okay, I can make something that's a little bit better braced. I can do different angles. I can do a few different things because there is no upper boundary. It's a little bit bigger, it's a little bit larger, and it has that sort of like aggressive refinement that makes it look a little more sports car-like. The M1 is maybe the most beautiful speaker I ever made.